This is a problem where we're going to be using L'Hopital's rule more than once. Note that x is going to 0, and when I plug in 0, I'm going to get 1 minus cosine of 0. Since cosine of 0 is 1, we get 1 minus 1, which is 0, and sine of 0 is also 0. So we get the indeterminate form 0 over 0. With that in mind, I go to the instructions for 0 over 0. It tells me to take the derivative of the top and the bottom. Okay, the derivative of the numerator here will be positive sine of 2x times a factor of 2 due to chain rule. The derivative of sine squared of 3x, what I recommend you do before you take this derivative is rewrite sine squared of 3x as sine of 3x all squared. That way we can see the outermost function is this squared. The 2 will come down in front, giving me 2 sine of 3x, and now the due power is 1. But then we have to remember the derivative of the inside function. The derivative of sine of 3x is cosine of 3x, and the derivative of the inside function inside the sine, the derivative of 3x, is 3. So a chain rule popped out the cosine, and another chain rule popped out the 3. Okay, we can do a little bit of simplification here. These 2's will cancel, but that's about it. I can't cancel sine 2x and sine 3x. So what do I have? I have a limit as x approaches 0 of sine of 2x, all divided by sine 3x times cosine 3x, and I'll move this 3 out in front. Okay, now let's plug in 0. Again, we should get a limit this time, but sometimes we don't. And when I plug in 0, sure enough, sine of 0 on top gives me 0. Sine of 0 down below here also gives me 0. So I get 0 over 0 again. Well, it doesn't matter that it happens multiple times. We're still going to follow the instructions, which tell us to take the derivative of the top and the bottom. When I do that here, I get cosine of 2x times 2 due to chain rule. I'm going to need to use the product rule to take the derivative of sine 3x times cosine 3x. So here I go. The derivative, I'm going to actually leave the 3 sine 3x alone for starters. So 3 sine 3x is left alone. The derivative of cosine 3x will be negative 3 sine 3x. Okay? Then we have plus, now we take the derivative of 3 sine 3x. That will be 3 sine 3x times 3. 3 cosine of 3x times 3. And then I'm going to leave the cosine of 3x alone. So cosine of 3x gets left alone. Okay, still, now we're going to take the limit as x goes to 0. When I plug in 0, this time, what do I get? Cosine of 0 is 1 times 2 is 2. Sine of 0, 0. So this term all goes away. Cosine of 0 is 1. Cosine of 0 is also 1. So we have 3 times 1 times 3 times 1, which is 9, for a final answer of 2/9.